Alright, in this lesson we're going to go over some different tricks for derivatives. In the last video we went over the definition of the derivative, what it means, and how to find it with that, let me switch to pencil, where like the limit of delta x approaches 0 of f of x plus delta x minus f of x all over delta x. This is just like the change in y over the change in x, like the slope, limit of the slope as the change in x approaches 0. That's our derivative. And you can have your function and you can plug in those values, eventually like simplify it, and then evaluate the limit, and that'll give you the derivative. But there are easier ways to do it, and well, we're going to go through that painstaking process one more time, just for practice, but also as a proof. First, d dx means the derivative of the function. We can like put that in parentheses, so this is what we're going to prove first. The derivative of ln of x, log base e of x, is always going to be 1 over x. Not always, like there is the chain rule, and we're going to account for that in the second half of this video. But for real quick, as a proof, let's just have f of x equals ln of x. And let's just start plugging stuff in. We have the lim of delta x approaches 0 of ln of, remember, x equals x plus delta x right here. So x plus delta x minus ln of x all over delta x. And hopefully you remember like your pre-calc. If not, we have some log rules which you probably don't remember them all. They suck. One is just ln of a minus ln of b can just be rewritten as ln of a over b. Don't want to write under my webcam. And another rule is ln of a to the b power can be rewritten as b times ln of a. Now, we want to simplify this so we can actually evaluate the limit. So let's use these two rules that we know from pre-calc and evaluate this. So what we can do is a minus b is a over b in ln. Well, if we have x plus delta x is a and x is just b, then we can just rewrite this as ln of x plus delta x over x all over delta x. And this right here, dividing by delta x, we can just rewrite this as, we can just rewrite this as multiplying as 1 over delta x. So, real quick, let's simplify this inside right here. We have x plus delta x over x. And this right here can just be rewritten as these two fractions. And these cancel, and you're just left with 1. So let's rewrite that. So 1 plus delta x over x, and we have logarithm of that natural log, all times 1 over delta x. Now, our second rule right here, ln of a to the b equals b times ln of a. Well, we can go in reverse. our exponent, or our b right here, is just 1 over delta x. So we can move that right there and rewrite this. So we have ln of 1 plus delta x over x to the 1 over delta x. So we're getting a little closer to evaluating this limit. Remember, this is a limit right here. But we're going to do one more step. We're just going to rewrite the terms a little bit, where let's say we used A, we used B. Let's say C equals delta x over x. And if we have that, then we can also say, if we just multiply x over, then C times x equals delta x. So, what does that do? Well, let's plug those in. And what we get is ln of 1 plus c times 1 over cx. Alright, what does that mean? Well, 1 over cx can be rewritten as 1 over c times 1 over x. So let's rewrite that real quick. We're getting really close, just stick with me. So 1 over c times 1 over x. Well, remember this right here? Well, let's just use this rule. Let's take our part of our b. We don't necessarily need to do the whole thing. We take that and we just put it in front. So we have 1 over x, and then ln of 1 plus c to the 1 over c. Alright, we're getting close. Let's make some room over here. So, one thing is, let's ignore this 1 over x part. Let's just look at this. The limit of ln of 1 plus c to the 1 over c power is actually the definition of the number e, 2.71828, etc. That is our natural logarithm. That's where the base e comes from. So you probably remember that from pre-calc. But anyways, any log with the same base as inside just equals 1. And remember that log base e, or ln, is just log base e. And that's what we have right here. Log base e of e, or ln of e, just equals 1. But we also have this 1 over x right here. So, remember, as delta x approaches 0, of this, well, this just cancels, and we're left with 1 over x. There's no delta x's in here, but if there were, we'd just plug in 0 and evaluate. But we are just left with 1 over x. So we can finally define d dx of ln of x equals 1 over x. And I only have 15 minutes, so I think we're going to end the video pretty soon here. And we'll do the definition of the power rule in the next video. But while I have the time, I'm going to just define something real quick. Actually, no, I'll do that in the other video. But what's important is if you have the function ln of x, which is something like this, what your points are on this line, but your instantaneous rate of change, your slope, will be tangent to that line. And well, that value of the tangent line is going to be 1 over x. It's just a cool little definition right there. Now, this isn't the case for, say, log base 2. Log base 2 is way more complicated, and we're actually going to prove that later, but maybe in a couple more videos. But next video, we're actually pretty much going to say goodbye to this gross definition right here. Like, we're going to come back for it in proofs, but we rarely actually have to do it the long way. So if you're struggling with this, don't worry, like, you want to understand it, but you're not going to have to do it very often, because there are shortcuts that I'm going to first prove like this, and then just forget about it.